Hello maths fans, I'm Dr. Tom Crawford. I teach maths at the University of Oxford and the University of Cambridge, but today I'm going to be taking a high school level maths exam from Ireland. The Leaving Certificate, or Leaving Cert as it's commonly known, is a qualification taken by students in Ireland who have remained at school to study until the age of 18. They take a range of subjects, however, I will be focusing on mathematics, and in particular, this is paper 1 at the higher level, and the exam is from the year 2023. This particular exam actually made the news back in the summer of 2023 for having some notoriously difficult questions. However, beyond this, I have no idea what those questions are, because as usual with these videos, I have not looked at the exam paper, I know nothing about the syllabus, nothing about the qualification. I'm simply going to open the exam for the very first time, try and work my way through the questions and explain my thought process, and the whole thing will be captured on video for you all to enjoy. Right, let's see what an Irish maths exam looks like. 2 sections, okay, concepts and skills, 150 marks. Section B, also 300 marks. This feels long. How long do I have? 2.5 hours. Okay, 2.5 hours. That's a long time. Hopefully I won't need 2.5 hours, but we'll see. 300 marks is a lot of marks. All right, what else have we got? Use pen. All right, great. Write my answers in the book. I'm clearly just going to write my answers on the iPad as usual. Diagrams are not to scale. You must write the make and model of your calculator here. I don't have one, so I guess NA on make and model of calculator. I really hope there aren't actual calculator questions. We'll see. All right, okay, question 1. Answer any 5 questions. So do I assume that means I need to pick my questions. 1, 2, how many have we got? 3, 4, 5, 6. Oh God, there are actual questions. Oh, but okay, I've got to pick 5 from 6. This is what happens when you have no idea what exam you've agreed to do on camera. All right, well, question 1 definitely looks fine. So I'm going to start with question 1, and we'll see what I make of the others later. Find the 2 values of m, which are real numbers, for which the modulus of 5 plus 3m is 11. Okay, so 1a, we want modulus of 5 plus 3m has to be 11. Now, the modulus means it's always going to be positive, so it could either be 11 or minus 11. So I'm simply going to solve those 2 cases. So we're going to say case 1, 5 plus 3m equals 11, and then we're going to say case 2, 5 plus 3m is minus 11, and I'm going to solve both of these. So that means that 3m is equal to 6, so m is 2 in the positive case, and if it was minus 11 in the negative case, we've got 3m is equal to, subtract another 5, so it is minus 16, so m is going to be minus 16 over 3. So they are my 2 solutions. That is 1a, which is, oh, I don't know how many marks. The whole thing is 30. All right, I guess we'll see. Okay, that was all right. B, for the real numbers h, j, and k, we have an expression. All right then, so B. 1 over h is equal to k over j plus k. Great, like that. And what does it want me to do? Express k in terms of h and j. So I think it just wants me to rearrange the equation, so you get k equals a function of h and j. Or maybe it means to solve it. But either way, I want k equals, right, is how I'm interpreting the question. So, all right, probably wants me to solve it. It's going to be, is it going to be a quadratic? Let's see. What can I do? I'm going to multiply up and say j plus k has to equal hk. Fine. So j is equal to hk minus k. So j is equal to k times h minus 1. So k in terms of h and j. So k equals j over h minus 1, unless, and maybe this seems too easy, maybe this is why it's hard, unless the denominator is 0. Because if h is 1, then this doesn't work. So this is true for h not equal to 1. Otherwise, h is 1. The equation is going to be j plus k equals k, in which case j is 0. So j would be 0, h is 1, and k is any real number. Would be one possible solution. I may have overcomplicated this. Otherwise, it's j over h minus 1. Right, express k in terms of h and j. Yeah. All right, let's go with it. That's 1b. Moving on to part C. Okay, x squared minus px plus 1, x squared, let's just write that out, is a factor of a cubic. Find the value of p and the value of r. Okay, so that is a factor. So that times something has to equal my cubic, right? Which is x cubed minus 2x, x cubed minus 2x, minus 3r. And I'm told p and r are real numbers and p is negative, so that's helpful to know. So p and r are real, and p is less than 0. All right, great. My plan here is I could try and do like polynomial division, but that, I don't really remember how to do that. It's been a while, so I'm going to just work out what that linear factor is that must go in that bracket, so that when you multiply the linear term by the quadratic, I have to get the cubic. That's what I'm going to try. Let's see. So I'm going to need an x here. Let's just use a different color because that now gives me x cubed. Now I'm going to get, so let's just write this out. So I'm going to get x cubed minus px squared. Now I don't want an x squared term, so I'm going to need to add something to make it disappear. So I think I need to add p to that, because if I add p, then I'm going to get plus px squared, which is what we want. Then I'm going to have minus p squared x from there, and then I'm going to have plus x from there, and then plus p. Okay. Okay. So, I'm not sure if this is right, which is why I'm looking confused, but anyway, so those two cancel. I'm happy with that. So what I've got from my equation, let's just write it out. If it's x squared minus px plus 1 times x plus p. So I'm saying that is equal to x cubed minus 2x minus 3r, but it's also the left-hand side, by expanding the bracket like I just did, is actually going to give me x cubed plus how many lots of x? I've got 1 minus p squared, lots of x, and then I've got plus p. So that, okay, so now if I equate coefficients, so I'm going to say this has to be minus 2, that has to be that. So 1 minus p squared has to be minus 2, so p squared is 3. So p is plus or minus root 3. They tell me p is negative. That makes sense because they're helping me out there. So p is minus root 3 since p is negative. Awesome. And then I now know that from the constant term, so this was the order x term, from the order 1 or the constant term, I know that p has to be minus 3r. So that's minus root 3 equals minus 3r. So r is root 3 divided by 3, and that's it. Yeah, all right. So p is minus root 3, and I think r is root 3 over 3, and fortunately the denominator is already rationalized, so I don't need to worry about the square root. Question 2. Now, I want to work out if I want to do this, don't I? Because there's one of these I don't do. So I have a function, minimums, love it, I'm going to differentiate. Limits, love it, like that. Ooh, draw a graph, sure. All right, I'm going to do question 2. I might regret this, I'm going to do question 2. So, question 2. Let's dive into this. So I know the first one, differentiation, which I like. So f of x, part A, is going to be equal to x squared plus bx plus c, x squared plus bx plus c, where B and C are real, awesome, has a local minimum. Okay, so minimum at 3 minus 1, and that's going to be x, and that's going to be f of 3 has to be minus 1. Okay, so if it's a minimum, that means the derivative will be 0 at that point, and the second derivative will be positive, because the gradient increases away from the minimum. So I'm just going to make those notes, so I know that f prime is 0 and f double prime. Because it's a minimum, that has to be positive. I imagine I'll need those things. Find the value of b and c in the equation. Right. So I'm going to solve basically the two things I just said. So let's do the derivative. So f prime of x is going to be 2x plus b, and that has to be 0 since minimum, which means turning point, 0 gradient. Well, it means 0 since minimum at x equals 3. That's what I should say. So what that's actually telling you is that 6 plus b is 0, so b is minus 6. Now, okay, so maybe the second derivative is just going to be 2, which is positive, so that's automatically true. So now how do I work out c? That's going to come from, I think, the y value. Okay, so let's think about this. Because I know the value of y, yeah. So the equation also tells me that when x is equal to 3, we must have f of x must be minus 1. So that's going to tell me that 9 plus b, I know what that is, but let's just write it as that for now, times 3 plus c has to be minus 1. B we've worked out is minus 6, so that's 9 minus 18 plus c is minus 1. Minus 9 plus c, let's do this carefully. Add 9 to both sides, c is 8. All right, so I think c is 8 and b is minus 6. Part B, it's a limit question. I feel like I picked to do this one because I saw the limit and thought it'd be fun to talk about. So question 2b. Find the value of the following limit where n is a natural number. Okay, so we want the limit as n goes to infinity of n over n plus 1, so that's going to have a limit of 1, plus n plus 1,000 over n, also has a limit 1, and then plus a third to the power n, which will tend to 0. Yes, so I think as n goes to infinity, I'm going to write this in red, so as n goes to infinity, this whole thing is just n over n, don't care about the 1, so this tends to 1. Again, don't care about the 1,000, they're just checking you understand the size of the constant, doesn't matter. So that also tends to 1. And then we have a number less than 1 to higher and higher power, so it gets smaller and smaller. So this is actually going to tend to 0. So I think the whole limit is 2, is going to be my answer. The limit is 2, and that was short and sweet. Assuming I got it correct, I may have done it entirely wrong, but we're going to keep on moving to number C and graphs. So the function g is defined in this range, okay? So g of x for x between 2 and minus 2, less than or equal to, great. Its graph is shown in each of the two diagrams below. I had a feeling I might regret the graph bit, but anyway, got lulled in by the limit, which was actually quite easy. So draw the graph of g of x minus 2. Okay, so they've given me the graph of g of x, so I'm going to copy that out, and we'll try and do it vaguely accurately. Because I do have dots on my page, so let's see if we can use these. So they reckon it's going from 2 to then, oh god, minus 1, 1. Right, so that's going to be minus 1, 1 is there. And it's going from 2, 3. So 2 across and 3 up. All right, so it's quite a small scale, but they're having it kind of do something curvy like this. And that's pretty much it. All right, great. And then they've got this steep bit that's going up through 3, like that. Okay, so taking the dots to be 1 unit space in both directions, that's their original one. So now we want g of x, so that's g of x. So I want g of x minus 2. So basically the whole thing just comes down by 2. So that was there, so that's now there. That was there, so it goes like that. And that just comes down to 2 on the y-axis, yes, so like that. Okay, so that right there is just g of x minus 2. It's a translation in the y direction by minus 2. Okay, on as large a domain as possible, the function is only defined between minus 2 and 2. Okay, I knew they were going to do this. I now want to do same thing, but they want me to do, this is part 2. Should label my parts. They want me to do g of x plus 3. Now this means shift 3 places to the left is what that's going to do, just remembering my graph transformations. So if I draw this one in blue, it's the original one, shifted 3 to the side. So it's going to go like that, and then it's going to go like that. Yes, okay, I'm happy with that. That's g of x plus 3. Awesome. And, oh, question 2 done. These are great. And I'm definitely doing question 3. Is that the whole... Oh, it's not the whole thing. But I want to do that. Oh, I don't really want to do logs. Ooh, okay. I'm looking at question 3. I really want to do part A because it's a cool proof, but I definitely don't like logs. Okay, question 4, I like complex numbers. Yes, big fan of complex numbers. I want to do number 5, derivatives. Yes, 100% want to do that. Yeah, no, I like that. And 6, I think I want to do. Yeah, integrals. All right. So I would say I've cheated and looked ahead, but you're supposed to look ahead. So I would argue I have demonstrated good exam technique. I very nearly started question 3 because I really want to prove root 2 is irrational. It's a really cool proof. But I don't like logs. I'm not sure I would remember all of the manipulations of logs in B and C. So I'm actually going to skip 3. I'm going to go ahead to question 4. You never know, maybe I'll come back and do 3. But for now, we're definitely moving on to question 4. Depends how hard 5 and 6 are, but 4 looks all right. I like complex numbers, so I'm going to jump in with that one. Right, in this question, I squared is minus 1, thank you. The complex number, ooh, okay. Is this A? Yes. Okay, so Z1 is 1 plus I, and I'm told that's a root of the equation, which is Z cubed plus 3 minus 2IZ plus P is equal to 0. Okay, find the value of P. Okay, so if this is a root, that means I get 0 when I sub it in. I could try and find the other factor, but that feels hard. So I think I can just sub it in, and I should get 0. So, but I've got a qubit. Oh. Fine, okay, so 1 plus I, let's square it, times 1 plus I is going to give me 1 plus 2I minus 1, so it's just 2I. That's nice. Okay, and then 1 plus I cubed is then just 2I times 1 plus I. So that's just 2I minus 2. Right, so if I sub in to the equation, then I'm going to get z cubed, so 2I minus 2, plus 3 minus 2I times 1 plus I, plus P is 0. Right, and is P complex? Yes, P is complex. Okay, good. That makes it easier. So I get 2I minus 2 plus 3 plus 3I minus 2I minus 2 times I squared becomes plus 2 plus P must be 0. So I've got 2I and a minus 2I and then a plus 2 and a minus 2. So I think I get 3 plus 3I plus p is 0, so p is equal to minus 3 minus 3 minus 3i. All right, let's put that in a box and keep it moving. B. Use de Moivre's theorem, love it, to find the value of w for which w squared is minus 1 plus root 3i. Okay, so tell me to use de Moivre's theorem. So de Moivre's theorem, not sure I would have known to use it otherwise, but let's write it out. Tells me that e to the I theta is cos theta plus I sine theta, or more generally, that's probably Euler's theorem. De Moivre is e to the ni theta is cos of n theta plus I sine of n theta. Right, so I'm thinking here, if I let w equal r e to the I theta, then I know that r squared e to the 2I theta has to be minus 1 plus root 3i. Fine. So, what's that going to tell me? But then if I take the modulus of that, okay, so let's work out r. So the modulus of w, the modulus of w squared. All right, so r squared is therefore equal to the modulus of this number. Not sure that's how you're meant to do it, but these are the thoughts coming into my head. The modulus of this. Yes, so the modulus of that is the square root of minus 1 squared plus root 3 squared. So that's the square root of 1 plus 3, which is root 4, which is 2, because r squared is very clearly positive. Okay, so I know that r is root 2, because it's a distance, must be positive. Now, I can work out the e to the I theta part, because, what do I know? I know that we need root, so r squared, so we've got 2 times e to the 2I theta, so times cos of 2 theta plus I sine of 2 theta, and that whole thing must be minus 1 plus root 3i. So I know that cos of 2 theta for the real part, therefore, because the real parts have to be equal and the imaginary parts have to be equal. So the real part tells me cos of 2 theta is minus a half, and then the imaginary part tells me that sine of 2 theta is root 3 over 2. So what on my graphs are going to give me this? So cos is going to look like this, and sine is going to, let's do a different color. So that needs to be at 0, so it's going to peak there, yeah, and then do that. Right, okay, so a bit pointy, but you get the idea. That's cos and sine. So I'm looking for a point when cos is negative a half, but cos of 2 theta is negative a half. Ooh. All right, so if cos is going to be negative a half, that's like down here. Okay, so this is negative a half. But then I want sine to be root 3 over 2. Ooh. Does that work? Does this work? I'm going to try a graphical approach. Now, this is probably not what you're meant to do, but I'm kind of a little bit stumped. So I'm going to try an argand diagram when I say graphical approach. So I know w squared, don't I, right? That's, yes. So w squared is minus 1 plus root 3i. So I should be able to work out the angle of w squared, which would be twice the angle of w, I think. Yeah, pretty sure that's true. All right, so let's try and draw. Might have been overcomplicating it. De Moivre's theorem has thrown me because I don't want to use it. Anyway, it's probably going to say in the mark scheme must use it, but who cares? If I get the right answer, I'm getting the marks. More than one way to do maths. So I've given myself enough justification now. We know that it's -1. So -1, and then we're going up √3, right? So let's just suppose it's there. Right, so this is w squared. So w squared, right, yeah. So this is w squared. So I know that w squared is, this is much easier than I made it. Because it's clearly w squared is 2, just from like Pythagoras, the diagonal is going to be 2, is 2 e to the I angle. Now, to figure out the angle, can't I? Yeah. So if I know these distances, it's 180 to go around. So that's going to be, I want to say, let's call this theta. I know that tan of theta is opposite is √3/1. Right, so the graph of tan, oh God. The graph of tan is √3 at theta equals 60. Yes, because I know tan of 45 degrees is 1. That's the one I always remember. Yeah, so it's 60. So theta is pi/3. Probably want me to use radians, I assume. So theta is pi/3. So so this is e to the I 2/3, 2 pi/3. Right, so therefore, w is √2 e to the I pi/3, which is going to be √2 times cosine of pi/3 plus I sine of pi/3. Great. So that is √2. Right, cos of 60. I drew my graphs up here, didn't I? Cos of 60 is the smaller one, so that has to be so it goes 1, and it goes √3/2, √2/2, 1/2. So it's a half. Okay, so I think that's a half. Plus I sine pi/3. Just had a thought about plus or minuses. I'll come back to that. Let me just make a note to think about plus or minuses. A half plus I sine of 60 is therefore √3/2. Okay. So that is W. Now, I could have a minus, couldn't I? And it would still make sense. So I was saying before that the radius r, the modulus, has to be positive, which is true, but I could take the minuses inside the e to the bit, ei theta bit. So I actually think, okay, so I know that, so I actually think there's a plus or minus here. So let's just plot that all the way through, because there should be two solutions, because it's a quadratic square equation. All right, so I think w is equal to either √2/2 plus I √3. Oh God, with the √2 on the top, so that's a √3/√2. Yes, or w is equal to minus √2/2 minus I √3/√2. Probably supposed to simplify that. So it's going to be √2/2 is okay, plus I, top and the bottom by √2 gives me a √6/2. Or minus √2/2 minus I 6/2. Now, I should really check and square this and make sure I get the answer, but I've already spent way too long on this question, so I'm just going to move on, because there is a part C. The eigendiagram, now we're doing eigendiagrams. Below shows the complex number u is equal to a plus bi. Right, u equals a plus bi. Awesome. And it's there. Write the complex numbers I, u, and I, u bar in their simplest form. Okay, well, that's complex conjugate. So, I times u, therefore, is ai minus b, I think is going to be its simplest form. And iu barred of the whole thing is therefore just ai minus b all barred. So when you take the conjugate, you just change the sign on the I. So that's just going to be minus ai minus b. Sweet. Plot and label, knew this was coming, on the diagram as accurately as possible. Okay, so again, obviously not to scale, but I can copy out what they've got, something like this. So they're saying U is up here. Okay, so I times U is a 90-degree rotation. I already know this. So again, I don't know if students taking this exam would know, but multiplying by I rotates by 90 degrees. So what you're going to get then is a 90-degree rotation. So we were previously A across and B up. And from the diagram, B is clearly larger. So now we are B across and A up. So this is now B, and we are just A up. So we're here. Okay, so this one should have used different colors, but that one is IU. Now I will use blue for the second one. IU bar is you take IU and you stick it down the bottom. So that's going to be down here. So, and let me just check that makes sense. We've gone minus B that way, yeah, and now we're at minus A that way. That's a minus. Okay, yeah, awesome. I'm happy with that. Great, yeah, perfect. Is that it? No, it's not it. There is a part 3. Okay, so that one was, this was C part 1. This was C part 2. So there is a C part 3. What do they want me to do? They want me to state a transformation that would send U. Okay, so we go from U to IU bar. Right, and I'm not allowed to include a translation. Very nice. So what have we done? We have reflected in the line Y. So this is just a reflection in the line Y is equal to minus X on that diagram. So in terms of imaginary parts and real parts, that would be the imaginary part is equal to negative real. That's what's happened. So it's a reflection in that line. I'm going to go with that. Okay, question 5. Okay, derivatives. I'm going to clearly do this one. So you don't need to worry about 3 yet. So f of x is 1 over 5x squared plus 7. Find the derivative, give your answer its simplest form. All right, so f prime is, so just to help myself out, this is 5x squared plus 7 to the minus 1. So then when I differentiate, I'm going to bring the power down. The chain rule says I differentiate 5x squared, so that's 10x from the chain rule. And then I've got this whole thing to the power minus 2. Great, as simple as that's going to go. Awesome. What am I doing next? I am given a function, so that was part A. I'm now given a function g of x. Complicated looking thing. Okay, g of x is tan of x over 2. Fine, that's okay. And then times log x. Right, sure. X is between 0 and pi. Okay, so that means tan will go between 0 and infinity. Right, great. So I'm just going to make a note to say this belongs to 0 to infinity. Awesome. Because tan of pi over 2 is indeed infinity, tends to it. Right, what am I doing? Find the value of g prime. Okay, so it wants g prime at pi over 2. So, chain rule, not chain rule, well, chain rule and product rule. Product rule. So if I differentiate tan, I get sec squared of x over 2. Derivative of tan is sec squared, and then a half from the chain rule times the thing I left alone. And then I could have also differentiated the log, and that would give me a 1 over x times tan of x over 2. Okay, great. And it wants this at pi over 2, so g prime of pi over 2 is, right? G prime of pi over 2, okay. So I want sec squared, which is 1 over cosine squared pi over 4, which is 45. So cosine of pi over 4 is cosine of 45 degrees, which is root 2 over 2. So when you square that, you're going to get 2 over 4. You're going to get a half. Okay, so that's going to be a half. Remember that. Times another half times log of pi over 2 plus 1 over x, so 2 over pi tan of pi over 4. All right, so summing in the bit I've already worked out, g prime of pi over 2 is therefore 1 over a half. Yes, so it's 2 times the half times log of pi over 2. Right, and I can't simplify the log. Now we've got plus 2 over pi tan of 45 is 1. Great, so just that. So I think then the answer is 2 over pi plus log ln of pi over 2. That's g prime of pi over 2, which is what they wanted. At least, supposed to be. Assuming I got it correct. Because a and b are real, they are both real, log of something. Awesome. Okay, part C. I like this question. Might be my favorite so far. Feel like I know what I'm doing. Diagram below shows 3 sets, a, b, and c, and 2 functions f and g. F goes from a to b, g goes from b to c. Excellent. Size of a is 4, size of g is 4, size of b is 3. Fine. Weird and wonderful, but okay. So it wants me to work out g of f of 3. Right, so f of 3 is the world, and then when you apply g, you get w. So that's just w. Okay? That feels a little bit easy, but we'll go with it. Part 2, explain why g mapping from b to c is injective, but not surjective. Okay, so injective means each element, what does it mean? It means each element is like 1-to-1, so maps uniquely. That's the key thing, yeah, maps uniquely. So e.g., we know that g of the plane, I'm going to write in words, g of the plane equals x. We know that g of the world, or the earth, is w, and we know that g of rain, cloud, is z. So there's only one, like, it's not like 2 things map to z, for example. So the other one, you have 2 and 3 for f. F maps both 2 and 3 to the world, so it's not 1-to-1. I know what it means, though. I'm convincing all of you I deserve the marks. But it's not onto, right, but it's not surjective, because surjective means everything in your input space is mapped to something, well, is mapped to everything in your output space, and that's not true. Not surjective, since nothing in B maps to the output space maps to Y. So you can't get to Y, so it can't be onto, because it has to map to every element in C, but it doesn't map to Y. Okay. Awesome. Right, that's question 5. Let's move on to question 6. Okay, so I have to decide, do I want to do 6 or go back and do 3 and logs, which I don't really want to do. Okay, it's integral. I'm gonna do 6. I like calculus. I teach calculus to my first years. All right, so we're gonna do Q6, which I think is gonna be the last one in section A. So let's go out with a bang. F and G are 2 functions. Okay, so f of x is x plus 4. G of x is x squared minus 2. Fabulous. Find the 2 values of x for which they are equal. Okay, and that's part A, part 1. Right, so we want f equals g, which means x squared minus 2 equals x plus 4. So that means x squared minus x minus 6 is 0. I can see how you're going to factorize that. So that's going to be an x minus 3 and an x plus 2 equals 0. So x equals 3 or minus 2. Sanity check. When x is 3, I get 7. I get 7. When x is minus 2, I get 2. I get 2. Excellent. Okay. They're my two answers. I've already given myself a tick, but that's to tell myself I checked them. They work. All right, find the area of the shaded region in the diagram below. The region between these two graphs. Okay, and I've already figured out the two roots. Wait, hang on. Yes, okay, fine. So I'm going to draw the diagram because, as usual, I'm writing on a blank page just to help myself out. So we've got the quadratic doing something like this, and then you've got this line F going across. Brilliant, and this is x plus 4, amazing, so that means that's 4. And we want to know the area between them, between -1 and between 2. Okay, so that means 2, and that's the area we want, right. So, how can I do this? If I work out the, the area between the two graphs. So if I were to work out the area under F, because if I were to integrate F between -1 and 2, that would give me an answer. Sure. But that's not going to be the extra bit that I want. So how else could I do this? Let me think. I've forgotten how to do integrals, apparently. So, right. So I've got F and I've got G. This is x squared minus 2. Right, so if I integrate x squared minus 2, I'm going to get the area underneath that graph. But here it's negative. So it would give me that bit plus that bit. Okay, but where does it cross? Maybe I should work out where it crosses. That might help. Okay, drawing a bit of a mind blank, which is interesting, because I clearly do know how to do this, but... Alright, so my thought is, this do I know where that crosses? I should know where that crosses. That's going to be root 2. Okay, so if I do... Alright, I'm going to use another colour, right? So if I do this particular integral, I'm going to write out in a minute. I think I'm going to get this area. So let's see. So I think if I do the integral of g, so the integral of x squared minus 2 dx between -1 and root 2. So I think this equals the green area. Possibly with a negative sign. In fact, it probably will be, but let's just do it. So I think it's going to be that. Writing the same thing out. So if I integrate it, I'm going to get x cubed over 3 minus 2x between -1 and root 2. Right, so if I sub those values in, so that's 2 times root 2 over 3 minus 2 root 2, and then minus minus a third, minus 2, so plus 2. Right, so I think we're going to get, oh god, 2/3 of root 2 minus 2 lots of it, so that's minus 4/3 of root 2, but then minus 2 plus a third. So subtract off 2 and then add on 1/3. So god, this is complicated. Clearly not the way to do it. So 2 minus 1/3 is 5/3, so minus 5/3. Okay, so minus 4/3 root 2 minus 5/3. So then if I turn that to a positive, I think that's going to be the green area. So I think the green area is, this is so not how you do it. is 4/3 root 2 minus 5/3. Okay, I think that's the green area. Now the blue area, well, let's call it the red area, in fact, between here. So this is just simple trapezium. So the red area is going to be equal to, this is so not the way to do this question. It's going to be equal to minus 1 up to root 2 of x plus 4 dx. So that's simply x squared over 2 plus 4x between minus 1 and root 2. So that's going to give me x squared, so 2 over 2, 1, plus 4 root 2, minus, so still becomes positive, and then minus 4. Great. So it's 1 plus 4 root 2 minus a half plus 4. So that area is going to be 5 minus a half, so 9 over 2. Plus 4 root 2 is the red area. So let's, to help me remember how this is working, let's just kind of add that red colour. So this is 9 over 2 plus 4 root 2. Okay. So there's this little bit left now that I want to work out here. So what I think I can do is actually go from root 2 to 2 of f and then subtract off the g term. So I can do these two together. So let's write it to the right hand side. So I think the black area is such a bad way to do this question. And I might even be doing it wrong. Root 2 to 2 of f, x plus 4 minus g. So minus x squared plus 2. Right, dx. And that's the black area. Because I'm doing the area under that one minus the area under the quadratic. Yes. Yeah. All right. So that is now going to give me. So it gives me an x squared over a 2. We've got plus 6, so plus 6x minus x cubed over 3 between root 2 and 2. So I'm going to get x squared 4 over 2, so 2 plus 12 minus 8/3. And then we subtract off, sub in the root 2's, 1 plus 6 root 2 minus 2 root 2 over 3. Okay, so tidying it up, that's going to give me 14 minus 1, so 13 from those three, minus 8 over 3 plus, no, nearly made a mistake, 6 root 2, and then plus 2 root 2 over 3. Okay, so I think the total area, which is what I've been asked to work out then, is red plus green plus black. Okay, so I think the answer is green, 4/3 root 2 minus 5/3, plus 9 over 2 plus 4 root 2. Oh, wait, that was a plus. Spotted an error I made there because it was flip the sign of the whole thing, so that's a plus. My bad, yeah. Plus 9 over 2 plus 4 root 2. And then finally, this black part. So plus 13 minus 8/3 minus 6 root 2 plus 2 root 2 over 3. Right, so if I simplify the whole thing, maybe this is one of those horrible questions I mentioned at the beginning. So I think the whole thing is, what have I got? I've got 4 over 3 root 2 plus another 2/3. So 4/3 plus 2/3 is 6/3 is 2 root 2. Plus another 6 root 2. No, plus another 4. So 6 root 2 minus 6 root 2. So all the root 2 terms go. This gives me more belief. 5/3 minus 8/3. So that's so that one and that one give me a minus 1. And then I've got 4.5 plus 13. So that's 9 over 2 plus 12, which is 16.5. So 33 over 2. All right. I think done in definitely not the correct way, but I got a nice answer. I think it's 33/2. Moving as swiftly on as I possibly can because that was ridiculous. As I said, maybe that's one of those crazy questions I don't know. Or maybe I just didn't know what I was doing and made a mess of it. Quite possible. But anyway, I'm supposed to be moving on to part B. Still not finished section A. Whew, this is long. Right, B is a positive constant and this is true. So 0 to B of B e to the bx dx has to be e. Right, so I'm just going to do the integral. And hopefully this is the last question on section A. So the left-hand side is, what's the integral of that? It's just e to the bx, I think, between 0 and b. Let me just check. Because if I differentiate e to the bx, I get b e to the bx, yes. So it's just that, which is then equal to e to the b squared minus 1. Right, yes. And I want that, which then I guess I'm going to write here, want that to equal e. So we have to solve e to the b squared equals 1 plus e. I mean, this is a whole thing. All right, sure. So I can say that b squared equals log of 1 plus e. So b is square root of that. Yeah, plus or minus the square root of log 1 plus e. I mean, I don't think is right, but that's what I'm getting, and I'm definitely spent way too much time on this. So we'll go with that. Oh, b's positive. All right, fine. Maybe I'm right then, who knows? B is greater than 0, so I think it's the square root of log of 1 plus e. All right, question 6 was hard, but there you go. Let's move on, I think now section B. Right, section B. Let's see how section B compares to section A. It says answer any 3 questions from this section, and they're apparently each worth 50 marks, which is a very daunting number of marks for a question to be worth. All right, so how many have I got? I've got 7, question 7, question 8. What else have I got? Question 8's long. Question 9. I'm assuming there'll be at least one more. Question 10. Is that going to be it? Yes. Okay. So I've got to do 3 out of 4. Right. Well, let's just start by looking at 7. Do I like the look of 7? Acceleration, sure. Average speed, derivatives. Yeah, I like this stuff. Minimum time. Okay. I think I'm going to do 7. It just kind of looks okay. So we'll dive on in. Number 7. Right, Fiona is driving on a motorway. Passes a point A. Her speed is given by this. Right, so we have an equation for speed. As a function of time is 2/3 t cubed minus 6t squared plus 13t plus 109. All right. So that's the speed. V is her speed, t minutes after, okay, passing the point A. Okay, so this is from A onwards. Okay, great. And t is between 0 and 5. I'm going to note all of this stuff down because I feel like these questions might possibly be a bit more involved. Work out her speed when she passes the point A. Okay, so V is the speed after passing it. So it's when t is 0. So her speed at A is simply V at t equals 0, which is 109. Probably have to give units, kilometers per hour. Okay. So that, I was about to say that's speeding, but it's not. I think that's actually within the speed limit, isn't it? My lack of knowledge there of Irish speed limits, but I think we're okay, Fiona. I think you're okay. Right. Okay, so yeah, great. Work out Fiona's acceleration. That is the rate at which her speed is increasing 5 minutes after she passes A. So the acceleration is the derivative, v prime. So that's simply 2t squared minus 12t plus 13 and we want to know her acceleration 5 minutes after, and t was the time in minutes. So we want v prime of 5. So that's 2 lots of 25 minus 12 lots of 5 plus 13. So that's 50 minus 60 minus 10, so that's 3. So her acceleration in kilometers per hour per minute, kilometers per hour per minute, km per hour over minute, I guess. So she's increasing her speed by 3 kilometers per hour, so it's going up by 3 every minute is the acceleration. Great. Okay, C. Find the time at which Fiona reaches her maximum speed during the first 4 minutes. Okay, so that is simply solving the derivative, the acceleration, being 0. Right? Yes. Maybe. Okay, well, it's asking me to do derivatives, which I've done. So the derivative is 2t squared minus 12t plus 13. So I'm interested in, could that be 0? So let's solve it equal to 0. 2t squared minus 12t plus 13 equals 0. Right, now I might have to use a quadratic formula. I'll use the formula just to be safe. So t is equal to minus b, 12, plus or minus the square root of b squared, 144, minus 4 times a, which is 2, times c, which is 13, all divided by 2a, which is 4. So t is equal to 12, actually let's just keep it simple, is a quarter, 12 plus or minus the square root of 144 minus 8 lots of 13. 5 of them is 65 plus another 39, so that's 94. Does that sound right? Yes, 94. No, what am I on about? 8 lots of 13 is 65 plus 39 is 104. Yes, it's 104. Okay. So t is equal to 3 plus or minus 1/4 times root 40. Okay, now I can take out, so t is 3 plus or minus, bring out a 4 and left with a root 10. So I can actually bring out an 8. No, I can bring out a root 8. So I can bring out a 2 root 2 times a root 5 all over 4. That's maybe not that helpful. All right, so it's 3 plus or minus a half root 5. Yes. Not root 5, root 10. My bad. Root 10. Yeah. Okay. Plus or minus root 10 over 2. Now, root 10 is like 3, so that's going to be bigger than 4. So the plus root's bigger than 4. So therefore, the max is at t equals 3 minus root 10 over 2, which is less than or equal to 4, because it says in those first 4 minutes. Now, so that's the time. It says give it decimal places, don't have a calculator, deal with it. And that will be okay, that will definitely be positive. Is it a max? That's the question, isn't it? So the second derivative, I think, means it will be a max. Let me just check. So the second derivative, v double prime of t, is going to be 4t minus 12. And for this to be a max, this should be negative. So as long as t is less than 3, which it is, so this is less than 0 at, let's call it t star. So therefore it is a max. Okay, awesome. There we go. Probably didn't need to do that, but I wanted to check for my own sake. Great. Part D. Use integration to work out Fiona's average speed over the 5 minutes after she passes point A. Okay. So what do we know? I know the... So if I work out the area... Oh God, I have to think about speed time graph stuff. Okay, so what have we got? We've got a function which looks something like this. I don't know. Between 0 and 5. Okay. Probably doesn't look like that, but it doesn't really matter. Something of this nature. And we're trying to say what? We're trying, yeah, because it's going to carry on like that and then go up like that, isn't it? Okay. So it does look something like that, I think, because it's a cubic, positive cubic. And this is time, and this is the speed. So if I integrate speed with respect to time, that's going to give me the distance, right? Is that correct? Because speed times time, which is kind of what I'm doing, is going to give me a distance, yes. So I don't really care about a distance. I want to know the average speed. But if I know the distance covered, and then I know the time, I can work it out. The average speed. Okay. Yes. Gotcha. So I reckon the distance covered is equal to the integral from 0 to 5 of the function, which is, where is the function? Written up there, 2/3 t cubed minus 6t squared plus 13t plus 109 dt. Right, so that's the distance, and then if I divide by the time, which is going to be divide by 5, give me the average speed. That's my approach. So let's integrate. So it's 2 increase the power divided by the new power. So it's over 12 t to the 4 minus increase the power divided by that. So 2t cubed plus 13 over 2t squared plus 109t between 0 and 5. So they've all got t's, so I don't have to worry about the 0 one. So it's just when it's 5. That's why we need a calculator, but here we are. 2 over 12 times 25 squared. Oh, Jesus Christ. 25 squared is... 25 is squared is 625, isn't it? Yeah, 625. Okay. Minus 2 lots of 5 cubed. 5 cubed is 125. Plus 13 over 2 lots of 25. Plus 109 times 5 is 1090 halved. It's 545. 545, yes. So, is this going to simplify? Probably not. So that's 1350 over 12 minus 250 plus 13 times 25, bloody hell, 250 plus another 3, 325 over 2 plus 545, right, great. So then that's the distance. So the average speed is just simply distance divided by time. And here time is 5. So it gives me 1350 over 60 minus 50 plus 325 divided by 5 is going to be 50. Wait, no, I'm doing this wrong. 13 times 5 is 65 over 2. Yes, 65 over 2, I agree. Plus 545 divided by 5, we're back to 109. Okay. All right, so it's whatever that number is, which I can tidy up a little bit and say is 135 over 6 plus 65 over 2 minus 50, so plus 59. All right, that's looks about right, maybe. 59, 135 over 6 is like 20, so it's like 79, plus another 30. Yeah, a bit faster than she was. I'm happy with that. Ballpark, feels correct. Don't have a calculator, deal with it. All right, part E. It is what it is at this point, as with all of these. You know, could get a calculator, but by this point, I'm just being, I'm just rebelling. Taking v prime to be the derivative of v and v double prime to be the second derivative. Okay, so we're told that v prime of 1 is positive. So that means The change in acceleration is positive, yes. But you're slowing down. So this means acceleration is greater than naught, but the derivative of it, slowing down rate of increase. Slowing down rate. So you're still speeding up, you're accelerating, but the rate at which you are is starting to tail off, is what that second derivative is telling me, being negative. Okay. 4 graphs are shown below. Okay. Close to where t equals 1, the graph of y equals v of t must look like one of the 4 graphs given above. I kind of drew v of t, so based on my picture, it's got to be b. Yeah, so I'm almost certain it's b, but let's see. Okay, write down which graph this is. Okay, so I think it's graph b, just based on the picture that I drew, but it wants me to give a justification. So the point is, v prime of 1 is positive, so we know that at 1 it must have a positive gradient. Yeah, so v prime of 1 positive means positive slope, positive gradient. Right, so that way, so it has to be b or d. Simple as that. And then I see now why they want me to explain. V prime of this being negative means gradient is decreasing. So it's getting shallower. So B is getting shallower. D is increasing, getting steeper. So that tells you it's B. So decreasing meaning shallower. There we go. All right. I got it from the picture I sketched out earlier. But I have hopefully satisfied what they want me to do. All right. This question is never ending. I can tell these are 50 markers. All right, there is an average speed zone on the motorway starting at the point A and ending at the point B. Distance from A to B is 10 kilometers. Okay, so A to B, and that's 10 km. Marvelous. Cameras record the time taken for the car to travel from A to B. Each car's average speed is then calculated. Work out, oh God, the minimum time in minutes a driver could get from A to B while not driving above. Okay, so so you're allowed to go. So if V is 100 kilometers per hour, so let's suppose you're driving at exactly the speed limit, 100 kilometers per hour, and you need to cover 10 km. So your distance is 10 km. Then your time, so speed equals d over t, just to make it really clear to myself, don't make any silly errors. V, speed is distance over time. So time is distance divided by speed. So time equals 10 over 100, which is 1/10 of an hour, which equals 6 minutes. So I think the fastest you can do it is going to be 6 minutes. Yes, minimum time. Perfect. All right, moving on to Rodhern. Okay, I've been watching a lot of Lord of the Rings, Rings of Power, recently, so I'm immediately picturing some kind of Rodhern plane and someone on a horse. But anyway, Rodhern, nice aside, is driving from A to B. Passes the point A at constant speed. Okay, so at A, B is 120 km per hour. Great. After 2 minutes, he starts to decelerate. Okay, so he's going, so if I'm drawing a speed time graph, he's going 120 for 0 to 2. Okay. At a constant rate until he reaches B. But by the end, he has to have an average of 100. Okay, so he then does this. So this is going at 120, yes. So he's going at 120, and then he goes until he reaches the point B. He decelerates all the way through. Okay, so this is A, this is B. Right, and then I know that this new height here is 100. Okay, and his average has to be 100 kilometers per hour. Okay. So, can work this out. So if his average, so he's going 120 times 2 minutes means it is equal to 120 times 1/30th of an hour. So he's covering there 4 km. Okay. So in those 2 minutes, he's covered 4 kilometers. So he has 6 kilometers left. So there are 6 kilometers remaining. And he clearly needs to be sufficiently slow that his average is 100. So if he's gone above that there. Okay. Okay. So I know his speed, I know his time, and I know that the area is 4 km. Yes. Great. So remaining, we know that this has an area of 6 km down to some unknown. No, he's at 100 at exactly B. Right, so I think I can work this out through areas, because I think I've got this kind of shape like this, where I know that this bit here is 20, I know this bit is 100, because he's going to be at 100. No, that's incorrect, Thomas. He's not ending at 100. He's at some unknown speed. Right, this is just some you who really knows or cares. Right, so start again. That's not right. But his average has to be 100. Okay. Right. Okay, so I can maybe still use my area approach. So I can say we have a shape like this. And I know that this is 120. This is some u that I don't know. That's his ending speed. But I do know that he has to cover 6 kilometers. So the total area here is 6 km. Okay, and then this is like some fractional amount. Sure. Maybe this isn't the way to do it. Okay, fine. How else can I do this? Okay. So, he's got to slow down sufficiently. So he's got to be going slower for some point of time. So this is not a very methodical way to do this, but I'm thinking if I just throw in what if he's going 100 halfway through, work out what that means, I can probably just slide that adjustment. It makes sense in my head. I'll try and explain now what I mean. So I'm thinking, what if he's going to pass through 100 partway through? So this is going to be 100, and this is going to be, having done 3. There's got to be a way to see this as an area, hasn't there? Yes, there has. So, the area, okay. So this is to do with what I just worked out, isn't it? So I just worked out that the average, okay, I'm going to rewrite this. So I worked out in the earlier part, the average speed is just equal to the total distance divided by the time taken. Right. Gotcha. That's it. So, he has to cover 10 km because that's fixed. We don't know t, but we know that his average has to be 100. Right. So that tells me I worked out t, didn't I? So the time taken, yes, so 100 km per hour times t has to equal 10 km. So t equals 1/10 of an hour. So t equals 6 minutes. Okay. So he's got to travel, there it is, got to travel for another 4 minutes. because his total time, yes. Okay, so that's at 2, which means this is now at 6, sorry, total, yes. So he's traveling between 2 minutes and 6 minutes, 4 minutes across the bottom. Okay, and he's got a constant slope down in those 4 minutes. Right. But what does he have to end up on so that the area is equal to 6 km? Okay, so what I know then is I know that if I put this as 0 to 4, right, and that's the speed he has, I've got to work that out, have I? Work out his deceleration, okay. Right, I have an idea in my head. So, I don't know the value he's going to end up at, no. So, what's the area of a trapezium? Oh, God. So I know that the area must equal 6, but it's also equal to the square, so 4u, and then plus the bit at the top, which is, I don't know the height. The height is 120 minus u times the width times a half. Okay, I think that's right. So 6 must be 4u plus 2 lots plus 240 minus 2u. So that's 2u plus 240. Now, that was kmph. That was minutes, which is not helpful. So maybe shouldn't have done it like that. That should have been in hours. So 4 minutes equals 1/15 of an hour. Okay, so let's change that number. This is fiddly. So rather than being 4, it's 1/15. Okay, so it's u over 15 plus that plus 1/15. Okay, so it's u over 15 plus, oh, I'm just going to have to redo this, aren't I? Okay, that's 1/30, so 1/30 is 4. 120 divided by 30 is 4 minus u over 30. Okay, so I think what it actually should be, tidying this up, is, we'll get there eventually, 6 equals u over 15 minus a 30th, so it gives me a u over 30 plus 4. So u over 30 is 2, so u equals 60. Right. This makes sense. So he ends on 60. Here, he's going 60. Right. So he's starting at 120. So he's going from 120 to 60, down to 60 in exactly 4 minutes, in 1/15 of an hour. So he's slowing down. So every minute, he slows down. So 60. So minus 60 kmph in 4 minutes. So his deceleration, therefore, is every minute he slows down by 15, minus 15 kmph, kilometers per hour per minute. So every minute he slows down by 15 kilometers per hour. Okay. I think. At this point, I've spent way too much time, so that's my answer. And is that the end? Thank God, that's the end of question 7. That one was long. All right, 2 to go. This already feels like a slog, and I've still got 100 marks left of the 300. Kind of running out of steam. This is long. This is long. Mainly because I feel like 7 was pretty awkward. Or, you know, maybe I made a mess of it. Who knows anymore? Who even knows? Okay, so 8 is, interest. Maybe I'll do interest. Financy stuff. Okay, 9 is, factors of numbers. I don't really like factors of numbers. It's like number theory-esque to me. Oh, gosh, okay. And then 10 is, what's 10? Geometry. Not a huge fan of geometry. Oh dear. Okay. Well, I feel like I'm probably going to do finance, and then one of those other two that I don't really like the look of. So let's get 8 out of the way. So question 8. Let's get stuck into some economics, if you will. Okay, Olga, Chen, Fiona, Fiona and Rohan are back, along with their friends Olga and Chen. All right, so Olga puts 3,000 euros. I like, obviously it makes sense it's euros, but I always like it when you have different currencies in these exams from different countries. 2,000 euros in savings. Interest is added at a rate of 2.4% per year. Okay, yeah, please be a compound interest question. Work out the amount after 5 years. Yay, it is a compound interest. So after 5 years, you'll have 3,000, but it's that times each year you add 1.024 and you take that to the power 5. Yes. Right, it's 3,000 times... I have to think about this now because it's 3,000 times 1.024 gives you an answer, and then it's times another 1.024 and then ... to the last one. Yeah. Okay, yeah. So whatever that is in a calculator, I'm not dealing with it. It's that. That's the answer. Anyone can put that into a calculator. All right, B. Explain what is meant by the present value. Oh gosh. Of a payment of 1,000 euros. Whoa. Explain what is meant by the present value of a payment of 1,000 euros in 1 year's time at a particular interest rate. What? Okay, so 1,000 euros in 1 year's time will have increased. Okay. So the 1,000 euros in 1 year's time will have increased to 1,000 times I, where I is the interest rate, right? Where I is the interest rate. Okay, this is a weird question. I'm not sure what I'm supposed to say, but what is meant by the present value of it? So therefore, the present value... Oh, it's 1,000 in a year. Okay. So we have... Okay, so if you let P equals present value, I get it. Then P times I, where I is the interest rate, will be 1,000. So P, the present value, is actually going to be 1,000 divided by I, where I is the interest rate. So again, because I have no clue what they actually want me to do here, I am just going to add an example. So e.g., in the first part, I was equal to 1.024, so P would be 1,000 divided by 1.024. All right, so it's kind of saying 1,000 in the future is actually what, could be like 970 now or something of that nature, right? That's the idea that I think it's getting at. Okay, is that what I'm supposed to do? Yeah, all right, whatever. Who knows? Number 2. Let's keep it moving. B part 2. Chen puts a different amount in a savings account with the same interest rate. After 6 years, Chen has 4,000 euros. Work out how much money Chen put in initially. Okay. So we have an unknown amount x, and we know that x, and then is multiplied by the interest rate. So 1 times 1.024, and that's happened 6 times because there were 6 years, has to equal 4,000. So therefore, x is simply 4,000 divided by 1.024 to the power 6. Again, I'm not putting that in a calculator. Deal with it. Cool. Okay, part C. Fiona is taking out a loan at the same annual interest rate, 2.4%. Fiona makes payments quarterly. Well done, Fiona. Nice work. 4 times per year. Work out the quarterly the quarterly interest rate. It'll be equivalent to an APR, which I assume means annual. I actually don't know what APR means. Of 2.4%. Give your answer as a percentage to 2 decimal places. Okay. All right. So, what are we trying to work out here? We need to work out the total interest. Okay, so the interest rate over the year. I think I get the idea the question is trying to get at. So I think the interest rate over the year is 1.024. Right? That's the 2.4%. Now, it's not as simple as saying 2.4% divided by 4 would give you 0.06. Sorry, would give you 0.6%, but you don't pay that 4 times because it's a power, it's compound, right? So that's, I think, what it's trying to test the understanding of. So it's not that, it's not 0.6. But what you would have to solve is we need 1 plus some number to the power 4 has to give us the same as if we paid the 2.4%. Right. So, how would I solve that? So I would say 1 plus I is 1.024 to the power of a quarter, which again, I would put in a calculator if I had one. So the interest rate is 1.024 to the power of a quarter minus 1. Again, I could put it in a calculator, deal with it. Right. Okay, D. Rodhern wants to put the same amount of money in a savings account at the start. I feel like I'm learning so much finance. At the start of each month for 36 months, so that at the end of 3 years, he will have a total of 12,000. And his interest rate is that. All right. Okay, think about this again. Same amount start of each month for 36 months. Okay, so after 36 months, we want the total to be 12,000. Okay. Yeah. Like it. And the interest rate is 0.11%. So that's 1.011 per month. That's the increase every month. Okay. Taking A to be the amount he puts in at the start of each month, write down a geometric series to show the total amount of money in the account at the end of 3 years. Okay, so he has A, and then after the second month, he has 1.0011 times A. Then, oh wait, but then he adds another A. But he had that at the beginning. Yes, so it's okay. All right, I think it's okay. Because after, so I was just thinking to myself, the month 1, he has A. The beginning, he has A. The month 1, he's got the percentage times A, because that's grown, plus the A he puts in. So it's okay. This is the total for 2 months. And then after month 3, he's got the 1 from the beginning, has this squared times A. So now I see why it's a geometric series. Plus the 1 from last month, and plus the 1 he's just put in right now, which is just A. So that's going to go all the way up to, so this is month 1, just to label this. So this is like month 36. This is month 35. This is month 34. So 2 months have passed. All the way down to month 1. So it's going to be 1.0011 to the 34. Do you want the first 2 and the first 2 and the last 2? Yeah, right. Times A. And then the last term, because this one would be from month 2, and then from month 1, because it's, wait, is that right? No, that would be month 2. Yes. Yeah, that's correct. I think that's correct. All right. Plus 1.0011 to the 35A So that was the one added in month 1. So yeah, 30, that many months have passed, I agree. And then 36 months have passed. So the end of the 36th month. Yes, the end of 3 years. Okay. So I'm happy with that. So he would not, therefore, have added... would he have added month 36? No, because that would be the start. Right. So I'm just going to put this in red. I don't think, if I've understood this correctly, there will be 36 terms because he's made 36 deposits. Right. So this is like at the start. Okay. Was that all I had to actually do? Yes. It's going to make me work this out though, isn't it? Hence find the value, yeah. So we want, right, so I have a geometric series, and I want the total is 12,000. So it's a geometric series. First term is 1.0011a. Yes, 1.011a. The common ratio is 1.0011, and there's a last term, which is 1.0011a to the 35. No, a to the 36. My bad. Yeah, okay. So, the sum of a geometric series, so the sum which we want to be 12,000 is, to think about this one now, it is, so you put the first term out the front, so that's common to all of them, and then it's, oh god, what is it? 1 plus the next term along. So 1.0011a to the 37. I think it's the first term times 1 plus the ratio to a higher, so it's not a to the 37, to the next term along. I think it's that. I think it's 1.0011 to the 37. No, because it would be... the whole thing should be the next term along, so that's 36. Okay. Slightly confused here, but I think that's right. I'm worried about balancing my indices. I'm going to go with that, and then it's over r minus 1 or 1 minus r. 1 minus r, yeah, is what I would put on the bottom. But that's not going to work. Because one of them, is that a minus? That might be a minus. And then it's 1 minus 1.0011. Trying to remember my geometric series formula. I'm going to prove the geometric series formula just to make, I don't want to make a silly error. Right, so if S is, it's A plus, and this is why I was getting a bit confused, because it's AR plus plus AR to the N. Then you say, well, if I did R times S, I get AR plus plus AR to the N plus 1. Okay, great. So I'm pulling out the A. So if I pull out the A, what I'm left with is a 1.0011 to the 35, having pulled out the A factor. Because then you do that top one minus the bottom one, yes, which is what I've written, and then, so you would do RS minus S over R minus 1, yeah, would equal AR to the N plus 1 minus A. So you say S times R minus 1 equals this. Yeah. So S is that over R minus 1, right? So it's actually that. Okay. Glad I checked. So I think it's that. Yeah. Okay, I think it's that. So if I put that into a calculator, so I'm going to, again, I'm going to be like, I'm not bothering with that. So 12,000 has to equal 1.0011 times A times 1.0011 to the 36 minus 1, all divided by 0.0011. Okay, so I would substitute that in. So A is simply equal to 12,000 times 0.0011 divided by 1.0011 multiplied by 1.0011 to the 36 minus 1. Okay, I have no idea what that's going to give me, but I think that's my answer. I am going to move on because, again, taking a while. All right, E. Park sells 3 types of ticket: child, student, adult. The table below gives information on the price of each ticket and the percentage of tickets sold. For example, 15% of all tickets sold are student. Yes. Okay. The expected value of the price of a ticket is 13. This is a whole other question now, isn't it? No more banking. Is 13.85. Okay. So E of X, expected value, is 13.85. Sure. Work out the value of X, the price of an adult ticket. Okay, so I think E of X is also equal to 11 times the probability, which is 0.52, plus the student price, which is X minus 5, yep, times 0.15, and then plus 0.33, sorry, times X. All right, solve for X. So we would say 13.85 is, 11 times 0.52 is 5.72 plus 0.15x minus 5 lots of that is 0.75 plus 0.33x. Okay, so 13.85. And then on that side, I've got 4.97, so minus 4.97 has to equal 0.48x. So I think x is equal to, it's going to be 8.85, 8.88 over 0.48. So it's kind of doubling it. It's like 18, 19 euros, something like that. Okay, cool. F, again, I'm not putting to a calculator. Can't be bothered. F. When an item is being sold, the markup is the profit as a percentage of the cost, and the margin is the profit as a percentage of the selling price. Okay. A shop sells an item with a margin, okay, margin of 18%. Work out the markup. Give your answer as a percentage. But I have no clue of the price it's selling it. Okay. Okay, so the margin is the profit as a percentage of the... Okay, so let's suppose the selling price... I'm just going to define my variables. There's a lot going on. Selling price equals P, right? P for price. Okay, and then we know the margin is the profit as a percentage of the selling price. So if I'm selling for P, then 18% of that is profit. So 0.18p is profit. Right, I'm selling it at P. I make 18% is the profit. So that's my profit. Okay. The markup is also the profit, but as a percentage of the cost. Okay, so I don't know that. So 0.18p is the profit. Let's call the cost price C. And I want to know the profit as a percentage of the cost. Oy, oy, oy. Shop sells an item with a margin of 18%. Okay. Now work out the markup for this item. But I don't know the cost price, do I? Ooh. Did not do any kind of economics, and I'm getting rather confused by the definitions. Okay, let's think about this again. Told you, it's a slog. My brain isn't working. The margin is the profit as a percentage of the selling price. Yes. Now, the markup, let's just write this out. The markup is the profit equals profit as a percentage of the cost. Oh, okay. Oh. Okay. So I want to say if the margin's 18%, then does that mean that the cost is 0.82p? I think, right? Because it's the cost. It costs you, right? So you're selling it. Let me just think about this. So let p equal 100. So then I'm saying the cost it costs 80, right, pounds, 82 euros, but I don't need a currency. It costs 82. And then I'm saying, so if I sell at 100, then my margin is 18%. So I make a profit of 18. Okay, so then the markup is the profit as a percentage of the cost. So I think the markup is 18 out of 82. That makes sense to me because the markup is the profit as a percentage, so it's a proportion of the cost. Yes. So 18 out of 82 is going to give me a number less than 1, so then I times by 100. Okay, to get percentage. All right. I'm still not sure I understand their definitions, but that makes sense to me looking at the numbers, right? I think I had a light bulb moment in my head where I was like, if that's 18, then I think the cost must be 82%. And then that allowed me to kind of go from there. Anyway, we're going with that. We're going with that. And that is, thankfully, the end of question 8. So now I just have to decide, am I going to do 9 or am I going to do 10? So I'm going to obviously look through both of them and make my choice. So I don't really want to do the number theory part of 9, but then it looks like derivatives, and I like derivatives, as we've seen. And 10 looks like a lot of geometry, and I don't think I've got the brain power for geometry. So yeah, I don't really like either, but I'm probably going to pick 9. Let's see what happens. Question 9. All right. Okay, Ava is investigating factors of different numbers. Looks at numbers written as powers of a prime. Okay, list the 5 different factors of 2 to the 4. Okay, well that's okay because it's prime factorization and it's already written like that. So, A part 1, the factors of 2 to the 4 are simply the other powers of 2. So 2 to the 0, 2 to the 1, 2 to the 2, 2 cubed, and 2 to the 4. They are 5 factors. How many different factors 3 to the 7 has? Same idea. So factors of 3 to the 7. So it's going to have 8 factors. So number is 8. I don't think I have to write them out, but right, I'll just write out the pattern. You're going to get 3 to the 0, 3 to the 1, all the way up to 3 to the 7. So it'll be 8 different powers of 3. Okay, maybe this one wasn't as bad as I thought. How many different factors? 2 to the 10 times, I think I know what they're getting at here. 2 to the 10 times 3 to the 12. Now, yeah, because, right, so 2 to the 10 has 11 factors. 3 to the 12 has 13 factors. So, you can pick a different number of them to combine. And you can, yes, so you pick one from each. So you can take them all by themselves, or you can pick them as pair. So I think it's 11 times 13. So I think it's 143 because it's all multiplied. So I think the total factors is just 11 times 13, which is going to be 143. So I think it's just as simple as that, actually. All right, B. All right, what's Ava doing now? I can get the relationship between pairs of factors. She makes a table to show the pairs of factors of 12. So the pairs of natural numbers, x and y, where x equals 12. Great, complete the table. Sure. X and y. Okay, so x goes 1, 2, 3, 4, 6, 12. 1, 2, 3, 4, 6, and 12. And then y would have to be 12. It would have to be 6. 3 times 4, 4 times 3, 6 times 2, 12 times 1. Okay, plot the 6 points above on the coordinate diagram below. One of the points is shown. So it's showing me when x is 3 and y is 4. So it's showing me that one. Okay, it's going to be nice and symmetric, that's for sure. So positive x and y. So when x is 3, y is 4. And then when x is 4, y is 3. And then when we go down to like 1, it's like up here at 12. Yeah, and then down here, this is 12, this is 1, and then 2, and then 6 in the middle. All right, and then 2, and then 6. And that's all of them? 1, 2, 3, 4, 6, 12. Yes, okay. Right, great. Do I want to join them up? I don't know if I'm going to join them up. I'm going to join them up. Because you're going to get this nice kind of pattern like this between them. Okay. Oh, I'm feathering. Sorry, Ben Sparks. For those of you that have seen my GCSE video, I am calling that correct. Screw you, Ben. Okay. 3. Ava realizes the relationship is this. Yes, see, that's what I drew. Right, hyperbola. Okay. So Ava has worked out very cleverly that y equals 12 over x. Awesome. On the coordinate diagram, draw the graph in the domain. Oh, I kind of did. All right, I already did. So yeah, so this is now just, this is literally y equals 12 over x. And he wants me to do in the domain between 1 and 12. Great. That's what I've done. Perfect. C. Awesome. Okay, so far I'm happy with my choice. It's going to get worse. Now I've said that. A tangent to the curve is drawn at a point P. So we have a tangent at P for x, and so y is 12 over P. Excellent, I agree with that. P is positive and a real number. Awesome. Show the equation of this tangent is this. Right. So, that's a straight line, yeah, okay. So the gradient is dy by dx, dy by dx, which is, so it's 12 times x to the minus 1, so it's going to be minus 12 over x squared. So therefore, the equation is y equals mx plus c, x plus c, where the gradient is the x value, so minus 12 over p squared. Yes, because you evaluate that at x equals p. So that's the first bit, right? And then we have to solve, so we know that y equals 12 over p when x is p. So that's going to give me c. So 12 over p has to be minus 12 over p squared times p plus c. Yeah, that does work. So that gives me 24 over p equals c, which is the answer. Okay, great. Awesome, tick. That's what we got. That's your intercept. Okay. Awesome. Show that the equation of the tangent is this. Done. Liking it. C2. The area of the triangle formed by the x, the y, and the tangent is always k square units. Wait, okay, hang on. The area of the triangle, okay, so area of triangle is equal to k, what's k, where k is a natural number. Okay, work out the value of k. Right, so it's saying it's always the same no matter the choice of p. So, right, so let's just think about this. So my graph is y equals this. So I am just going to take, so what have I got? It's y equals minus 12 over p squared. X plus c, where c is 24 over p. So if I take p to be 12, right? So I'm going to let p equal 12 to make my life hopefully a bit easier, because it's telling me it's always the same. So therefore my line is minus x plus 2. So now I know that it's going through 2, and it has a gradient of minus x. So it's going to look like this. So therefore it's a triangle of side lengths 2, so the total area is 2. So the area equals 2, which implies k equals 2. All right, cool. I don't think I would have immediately realized they were always the same. Kind of does make sense though, I think. But yeah, I'm happy with that, because it's saying pick a value of p. Wait, that's not correct. Whew, I think I spotted my mistake, because it's p squared, isn't it? That's wrong. My bad. That was lucky. It's p squared. It's p squared. So I don't want p to be 12. Let's take p equals 2. Let's take p equals 2. My idea will still work, because I can pick any value of p to make my job easy. I just did a silly. Because I'm going to let p equal 2, which I know is a point on the curve, because now I can say y is equal to minus 12 over 4 times x plus 12. So actually y is equal to minus 3x plus 12. Right, that makes more sense. It seemed too small, the answer I got. So what you're actually going to look like over here, redraw this, is you're going to go through 12, and it's going to come down quite steep. So when y is 0, x has to be 4. So it's going to look like that. Let's draw it more like that. So this is 4. So the area is actually 24, right? Because the area of that triangle is a half times 12 times 4. So it's 24, which is k. Okay, so k is actually 24, which I find more believable, thinking about the picture in my head, yeah. All right, I'm going to go with that. So I think k is 24, and let's keep it moving. Oh no, that's it. Oh, well that one was short. Is that really it? That can't be it. Okay, no, that is it. All right, well, whew. Okay, so a surprising end there. That one was so much easier. Number 9 there was so much easier than 7 and 8. So maybe 8 was one of those other awkward questions. I feel like 7 and 8 were both actually a little bit tricky. They might have been the hard questions. Who knows? I can actually look up the newspaper articles now and find out. But before I do that, as usual, I've stopped, I've finished, done the exam. It's taken a while, I'm exhausted. I do need to mark it, or at least check that I've got the right answers, the right working. So take a little break. I'm going to go and get myself a drink at least. And I'll be back in just a moment to do the marking. And then I'll kind of rank where does Ireland sit in my list of international high school maths exams. Right, I'm feeling refreshed and ready to do some marking. So let's see how I got on. I have the mark scheme in front of me. I will also, as usual, put the mark scheme and the exam paper in the video description so you can have a go at these questions yourself, and also check that I have marked my own answers correctly, apart from, not having a calculator. We're just going to ignore that. But otherwise, I'm feeling really confident. There are some hard questions, so, we'll see. My confidence might be misplaced. But I feel like most of my answers seemed reasonable. So, as usual, I'm not going to focus on exactly the very specifics of the mark scheme. If I have the correct answer, I'm giving myself the marks. That's how we're going to do it. Otherwise, this will be a whole other hour of marking. And at this point, I'm tired, you're tired, we just want to know how I did. Question 1. M is 2 or minus 16 over 3. Boom. B. K is j over h minus 1. K is j over h minus 1. It doesn't mention the 0 thing, but that's fine. I just did more, right? So that's fine. I'm claiming that's okay. P is minus root 3, yes. R is root 3 over 3, amazing. That's question 1. Okay, so that's 30 out of 30. Good start. I was expecting that one to have been okay. Okay, C is 8, B is minus 6. That sounds like what I got. Amazing. The limit, that was quite a nice one. That was 2. Pretty straightforward for me, at least. The graphs, so it's been shifted down to amazing, and then it's been shifted left. Amazing, and that looks perfect. Yeah. Yep. All right, awesome. And that was it. All right, another 30 out of 30. Forgot how nice these early questions were. Number 3. Oh no, I didn't do number 3. I left out number 3. I went to 4. Yeah. Okay. P is minus 5, minus 3. Oh, wait. I might have dropped marks. Oh dear. And this is out of 5. Oh gosh. Okay. So what have I done wrong? They reckon that I should have one. Oh wait. I've done the wrong question. I might have written out the wrong question. Let me look at this. I think one of us, me or the mark scheme, has answered the wrong question. It's probably me. Oh gosh. Okay. So I've done cubed, which I thought was kind of annoyingly difficult. I think it might have meant to have been squared. It is. It's z squared, right. So I have answered the wrong question. Good one for me, but I've lost marks. It's fine. That right there should be z squared, and I have written z cubed. So I have solved the wrong question. Now, I've got to give myself 0, 2, 3, or 5. What am I going to get? Let's see. Low partial credit. Some correct substitution or multiplication. I definitely got that. High partial credit is fully correct substitution and multiplication. So I am going to argue that I deserve 3 because here that's high partial credit. The mark scheme says basically if you've done everything correct but just not got the answer, then you deserve full credit. And I'm pretty sure what I've done is correct. I've just messed up at the end because I'm an idiot and wrote out the wrong question. So I'm going to say that's 3 out of 5. So I have got a big old -2 on that one. And, you know, lesson learned. Read the question, double check the question after you've read it. I answered the question I wanted to answer instead of the question in front of me. Ay. Okay, B. Oh, this one was a nightmare. What is W? Okay, it's root 2 over 2 plus root 6 over 2i. That kind of rings a bell. Root 2 over 2 plus root 6. Oh, get in. I'm actually really happy I got that. I've not used their method at all, but who cares? Minus. Oh, amazing. Get in. All right. Good. And there's a solid 15, so I get 15 for that. Awesome. And then the last 10 are going to be down here. Right, so I need to get I times U is, oh gosh, what does it say? Is AI minus B? Yes, and then when I bar it, it's minus B minus that, yes. Minus B plus AI for the other one. Yes. Yeah, cool. So they're all correct. Number 2, yeah, that looks correct. That looks correct. Okay. Ooh, this bit at the end. Okay, phew. It says axial symmetry in a line through the origin with slope -1, which is exactly what I said. I said it's a reflection in that line. Amazing. So I get 28 out of 30. Question 4. Answer the wrong question. Don't mind that. It is what it is. Silly error, which I shouldn't have made and none of you should make, but whatever. My maths was fine, I think. Okay, minus 10x over 5x squared plus 7 squared. Awesome. That can't be 15 marks. Wow. Okay. Next one is 2 over pi plus log pi over 2. Awesome. And then we've got W. Yep. Okay, this injective bit. No element of C is used more than once, means each element maps uniquely. Yeah. So I've said that. Perfect. And it's not surjective because one element of C is not used. Nothing in B maps to Y. Awesome. Yeah. Weird question, but I think that's a 30 out of 30 for that. Right. 50 markers. Still sounds like a crazy high number for a question. Number 6. 33 over 2 units. That rings a bell. That does ring. Well, wait. There was more before that. I've scrolled too far. Got too excited. X is 3 and X is minus 2. Yes. Already ticked that one. And then 33 over 2 units squared. Oh, get in. That one, again, I don't think I did the right method. But got the right answer. That's all that matters. And is that it? No. Oh! And somehow I got that one correct. The square root of log of that. Awesome. This wasn't a 50 marker, was it? This was another 30. Getting ahead of myself. Right. Because I skipped question 4. Or 3, or whichever one it was. Okay. Now we get to the 50 markers. Okay. 109. Yes. 3 kilometers per hour per minute. Yes. Right. I didn't use a calculator. 1.42. I'm pretty sure 1.42. And I did check the gradient. Amazing. That is going to be 1.42. I'm certain it is. So that's all good. Awesome. And then part D. Oh yeah, this horrible number I didn't want to work out. I'm pretty sure that's what I've got because they've integrated and then divided by 5. Yeah. Okay. I'm going to trust my algebra there. It looks pretty much like it's going to be 112.33, to be honest. Yes. Wait. Oh, you know what? It is. It's near enough. It's clearly going to be that, or very, very close to that. I did the right thing. It's fine. Okay. Question 7. Answer B, because the function is increasing and the rate of increase is slowing. Yes. Amazing. Now the horrible one. Oh no, time was 6 minutes. Yep, figured that out. Come on. Oh, deceleration, 15 kilometers per hour per minute. Get in. And there was such an easier way to do it than how I did. But you know what? It's kind of nice when you figure it out from a very convoluted, confusing way. There's I get a lot of satisfaction, the fact I was still able to figure it out. There is a much easier way to do it, given in the mark scheme, which you can take a look at. My job here is not to teach you anymore, it's just to see what I scored. So I did get the right answer, thankfully. Right, economics 1, number 8. Have I got that formula? I do have that formula, so therefore that's correct. Have I got that formula? Divided by 1.024 to the 6. Yes. Awesome, that's correct. Did it explain it's the amount that should be invested today to give you 1,000 in that time? I mean, yes. Weird question. Okay, great. That was B. C. Oh, that to the quarter minus 1. Awesome, just didn't put it in a calculator. Amazing. Geometric series. Okay, so I got lazy again, but I've got 12,000 times 0. That, yeah. And then 1 minus that, but I've got that minus 1 because of the flip. Oh, get it. Yes. It's the right formula. Again, I've not put it in. It would come out the same answer. 326 euros and 60 cents a month would what you would be investing. Okay, X is 8.88 over 0.48. Brilliant. Oh God. 9 out of 41 times 100. That's what I've written. I've written as 18 over 82. Same thing. Wicked. That is correct. All right, question 9. Nearly there. This is the last one, isn't it? Because I didn't do 10. Because I didn't have to. Didn't even really read it properly, but didn't look nice. Okay, question 9. Factors are... yeah, just the powers of 2. Amazing. Okay, it just wanted me to say there were 8. Awesome. 143 factors. Brilliant. That is my graph. Yes. This is looking good. This is looking good. Okay, and then finds dy by dx, and then works out the intercept by subbing in the y value. Yep, brilliant. And k is what? Come on, 24 units squared. And that's it, 50 out of 50. And the one above was also 50 out of 50, wasn't it? Somehow, that was 50 out of 50. And then the other one, was that also? I think it was, you know. I got so excited that I got the deceleration correct. Forgot to write the mark. So I think I've actually, everything I'm going to claim, all of the maths I wrote down was somehow correct. This doesn't happen often, so I'm going to make the most of it and emphasize this. Everything I wrote down was correct, but I misread one of the questions. So on the complex number question, I misread it as z cubed, so I actually got the wrong answer, so I dropped 2 marks. So I've scored there a final total of 298 out of 300, which I am extremely pleased with because that was a long slog of an exam. There you go, 298 out of 300. Obviously a very good mark, as I absolutely should be getting. But I think the challenge there for me taking that was I got a bit puzzled on the economic stuff, right? That sort of margin versus markup. I've just never studied it. So like I was kind of tired having slogged through all of those questions, and my brain was getting fatigued. So I did struggle a little bit to kind of get my head around that first, and I sort of fortunately guessed correctly using a bit of common sense. So that I had to sort of puzzle about a little bit. And I think on some of the integration question for the area, I definitely did that not at all the best way to do it, but you know, I managed to get there. So I think it's an example showing you that, you know, whilst there are methods to follow, if you can't remember them or figure them out, like you can still just do sensible things, just do maths to get the answer, right? There's more than one way to solve these problems. And even in the mark scheme, it was giving method 1, 2, 3. I didn't look in detail because I, again, wanted to be quick, just work out my total. But I feel like I've definitely used some slightly different methods, especially on those integration questions and that deceleration question. My method there was so different to what was in the mark scheme, but I don't care. I got it right. That's all that matters. From my perspective, at least. I'm sure teachers will tell me something different, but nonetheless. Now, difficulty. So I did, after finishing the exam, I did look up before I marked it, the hard questions. And it was the stuff to do with injective and surjective. The question about showing root 2 was irrational came up as one of the hard questions. So actually, I know that proof. I didn't do that question because I didn't like the rest of it about logs, but I do know that proof. So to me, that wasn't hard. But if, as a student, if you don't remember that proof or didn't pay attention to it, that's going to look like a horrible question. And then the surjective and injective, again, if you don't recognize those words, you're going to be like, what the hell is going on? So I can see why some students came out being like, what are they testing here? This is like nothing I've seen before. I am sympathetic to your cause, but I actually, for me, again, university level, of course, I found the more computational ones where I'd just forgotten the techniques. I found those a bit harder. And the time, it was a slog. It was absolutely a slog, right? 300 marks. I need to lie down, right? I'm exhausted. So I think it was all right overall. Where does it fit on my list? It felt like an A-level exam is sort of, I've forgotten all of the ones I have on the list. You can see them on screen, but I can't remember right now. I've done that many now, but it feels like it wasn't quite as hard as further maths. It feels sort of similar to A-level. I feel like I have the arbiter from Germany is a bit harder than A-level. This felt very, very similar to A-level. So when I'm editing this, as I'm currently now recording, you'll be able to see I'll slot it in somewhere around A-level, but how it compares to the others, you can see on screen because I just can't remember all the others I've done. You can tell my brain has just, it's gone, right? I've just done a 2.5 hour exam. I'm pretty exhausted. So my brain's melted. I can't remember the full list, but it felt like A-level. So therefore it's going to be harder than the American ones that I've been doing, but not, there were more advanced concepts in AP calculus. So maybe it's not as hard as AP Calculus, just because that one had more advanced concepts, right? There was like sequences and series and harder limit stuff in AP Calculus. So I think it's not as bad as that. Don't think it's quite as hard as the German, the Arbiter. So it's somewhere between A-level and Arbiter, I think, is where it's going to fit on the list. But again, you can all see it on screen. That's the ranking. Right, so I'm going to go take that lie down I keep going on about. I'm pretty exhausted. Thank you for suggesting exams. Please do keep suggesting exams. I want to do as many countries as possible. I am slowly trying to diversify away from just English speaking. So I've done Germany. It would be nice to get a few more translations. So if you have an exam you'd like me to do, maybe from your home country, and you are able to find an English version or send me a translation, then please do. I'm trying to do as many different countries as I can. But thank you as always for watching, and thank you for supporting the channel. If you would like to increase your support for the channel, then you can either sign up for my Patreon, more details are in the video description, or completely free option is you can subscribe and then you'll get notifications the next time I release a video. But thank you for watching, and I'll see you all soon. Take care.